right, so I think we can start. Can you all hear me? Yeah? Good. All right. So welcome to my talk, behind the scenes of JUnit 5, running an independent open source project by example. This is me. I'm Mark Philipp. I'm a software engineer. I'm currently self-employed, and I've become a JUnit committer in 2012, so quite a while ago, and have also been the team lead for quite some time, since 2016. JUnit is the open source project we're going to talk about today. In a nutshell, JUnit was originally created by Kent Beck and Erich Gamma, famously on the way to some conference on the plane. It's an independent open source project. That means it's not backed by a company or part of any foundation. So most of the work happens in the spare time of contributors. And at the same time, it's also one of the most popular Java libraries. So there's like a bit of a conflict here in some terms, in some way. And the agenda for today is we're not going to talk so much about JUnit features. We are more about, like, on the meta level, how have we been evolving JUnit over the past 10 years. So I'm going to start with a brief project history as I see it, and we're going to go over some lessons learned in a few categories, what we've tried and what we've maybe failed at or what succeeded over the last 10 years. And last but not least, we're going to compare JUnit then, 10 years ago, versus now. Little disclaimer, just need to zoom this in a bit here. This was actually a social media post, I think it was LinkedIn, from the OCX organizers that said, I will reveal the secret sauce for running open source initiatives successfully. Well, I hate to disappoint you, but there is no secret sauce. Every project is different, right? So what worked for us might not work for you. Just take it with a grain of salt. All right, just to see that everyone's awake, a quick show of hands. Who has heard of JUnit before? Everyone, okay. Who has written a JUnit test in the last week? Okay, not too bad. Who would consider themselves the maintainer of an open source project? All right, thanks. All right, so let's get into it. What JUnit has been over the past years. So my story started in 2010. I was really hardcore user of JUnit. I really loved writing tests. So in 2010, I did my first ever conference talk on JUnit because there were so many features of JUnit, like rules and all these things, that I saw no one was using, and I was trying to make them more known, so people would actually start using them. And over that time, also started contributing to JUnit. I picked up issues. I worked on PRs. The one I most remember is this one, upgrade to Hamcrest 1.3, which sounds simple, but there were many kind of compatibility considerations to be taken and to fix things in a way that people's tests wouldn't break when they upgrade, right? So that kind of took from March to August 2012. And when it was finally merged, I was really eager to use it. So I asked for a release. And the team said, well, we don't have any time. How about you do it? And basically, that's how I got commit rights. And so you have to be careful with asking those questions if you don't want to become a committer. All right. So I started, working on JUnit more and more. Over time, I again and again kind of hit this architecture problem, so to speak. JUnit started as a very small library, right? A framework more. So JUnit tests were written using the annotations, testing frameworks like Spock, but we're also using it as a way of integrating into IDEs and build tools without having official Spock support, for example. There were extensions to JUnit 4 that were, of course, using parts of the API. And IDEs and build tools sometimes, found creative ways of implementing things so they could work around of JUnit's limitations. So there's a really deep integration into like the JUnit jar. There was only one jar, right? And it was sometimes really hard to know which part was used by who and what would break if we changed this and such things, right? So for example, that's probably too small to see, but we changed field names. Someone was like modernizing the code base. There was a PR that renamed F expected into expected inside some class. And you wouldn't expect anything to break, but it did, right? So like even small changes such as this had to be done very carefully. So this kind of happened, and in a way, as my then colleague Johannes Links described it, the success of JUnit as a platform prevented the development of JUnit as a tool, because we constantly hit this kind of problem, and it was really hard to evolve JUnit anymore, because it was used by build tools and IDEs very deeply. And there was other problems. It also had two competing extension models. There was rules and runners. You couldn't combine them. It had to stay compatible with Java 5. At least, that was our goal at the time, to not, just bump up the JDK requirement without having a good reason to do so. So eventually, I kind of shared these frustrations at some conference. In my case, it was like Socrates 2014. And I met some people. We had a session about it. We discussed it. And basically, we came out of that session with the question, what if we actually had dedicated time to work on JUnit? What could we achieve? What would we do? And this is how this whole JUnit Lambda thing came to be, which was like a crowdfunding campaign that we did in 2015. And we raised about 50,000 euros to sponsor 2 developers for 6 weeks. And additionally, we found 4 other people, basically me included, that had an employer who would give the time to them to work on JUnit for 6 weeks. So we thought, 6 weeks, that's awesome. We could really make a dent. So what do we do first? And we had a kickoff meeting after the successful crowdfunding campaign to kind of bring the new team together who had never worked together, or at least only in parts. And we also invited people from our sponsors, but also from IDEs and build tool developers. So for example, we had someone from Eclipse here, someone from IntelliJ, someone from Gradle. And we had a week together and kind of brainstormed what we thought we should do and what we thought IDEs should consume. And they kind of corrected our assumptions in some form. So it was really a productive week. And we kind of had some decisions at the end of it. So we decided we would start from scratch with a new architecture. So we'd not continue to evolve the JUnit kind of code in a way. We would, of course, take inspiration from it. And we would also implement a compatibility layer so you could still run old tests using this new thing, whatever it will be. At the same time, we also wanted to rethink JUnit's extensibility story, like runners versus rules. Like there should be like a one concept, that's kind of composable, ideally. And we also wanted to embrace Java 8 features, which was like the Java release we had all been waiting for at the time, with lambdas and everything, and streams and so on. So that's kind of a decision we also took. We wanted to kind of break off the baseline from Java 5. So we set to work. The first 6 weeks in 2015, we quickly arrived at this new architecture. So we had a platform that was kind of completely agnostic of how you write a test, and it separated that other part from the engine concept, which would actually know like, okay, what is actually a test? How do tests look? And how exactly do I run them? And IDEs and build tools would use the platform, not the engines directly. So it was like a separation of concerns in a way. And we also came to a new extension model for writing kind of extensions for the testing framework. Of course, we heavily debated naming of everything, packages, class names, whatever. That was kind of the first 6 weeks, but it was we were off to a good start. However, as it goes, life got in the way. It took us more than 6 weeks, of course, to finish this, which was obvious. But we did a first alpha in February 2016. We decided to rename things and did a bunch of milestone releases. And then, eventually in September 2017, the 5.0 release was shipped. And since then, we haven't stopped work, since otherwise I wouldn't be here today. We ship, a feature release at least every year. So there's like 11, and of course, numerous patch releases. The last one actually just yesterday. And at some point we're like, okay, this is all good. Actually, we're working together pretty well, but it would be really nice if we had some budget to meet, to discuss some things face to face. So that's when we started in 2019 to collect donations, ideally monthly, via kind of a subscription thing on a platform called Steady. So companies and individuals could use this platform. They are, would take care of all the invoicing and everything. So everything is like correct, in tax terms and everything. We wouldn't have to worry about this ourselves. Yeah, and we are still doing this until today, and we're, gaining about 2,000 euros per month, which is obviously not enough to pay for anyone to work full-time on JUnit. But it did allow us, to meet, and we will again meet as well soon. So every now and then we can meet using the money, to pay for travel expenses, hotels, everything. And this is really useful for us, and we'll keep this going for sure. This is actually a list of sponsors, so you can sponsor JUnit. There's also like an individual list of backers, just people paying out of their own pocket. But if you're working for a big company and use JUnit a lot, would be nice if you could, bring this up to your boss and, just ask, there's this possibility. Maybe we could do it as well. Yeah, just food for thought. All right, let's talk quickly about adoption. So this is today, actually September 2024. JUnit Jupyter has now 50 million downloads per month from Maven Central. We started very small, as you can see. So this is the first time we actually reached the 50 million downloads last month. And this is also the first time last month it was higher than JUnit 4. So JUnit 3 now has 27 million downloads per month, JUnit 4, 45. And JUnit Jupyter, which is the new testing framework, part of JUnit 5, has 50 million downloads per month. So that's a significant milestone for us. You can also see the JUnit 5 BOM, which kind of binds everything together. The compatibility layer known as Vintage Engine, the platform, and the Jupyter, the testing framework. So these kind of dependency declarations are used more widely than JUnit Jupyter, which is great. That actually shows that the platform is actually used by many people. And there are other test engines like Spock, for example, or CodeTest that actually have engine implementations. So they work out of the box with anything that supports JUnit 5. Another significant milestone was that new projects, so if you use like Spring's initializer or the Gradle init task, use the JUnit platform by default. So they don't generate a template with JUnit 4 anymore, but you get Jupyter tests, and you kind of get started with the modern testing framework right away. And another interesting number is the number of repositories on GitHub that use JUnit, which is right now at 465,000. Yeah, so that gives you an idea that it's widely used, and it is going pretty well in terms of adoption. Yes, that concludes our first part. I'm being filmed here, but I still want to take a sip. All right. So this is like a very brief summary of what happened in the last 10 years. I want to talk more about what did we learn along the way now. And the first category is in technical terms. What did we learn? What was kind of essential? And one of these things was definitely backward compatibility. So even though we decided we would start from scratch, we knew we had to provide a way to run existing tests on the new platform. Otherwise, we would never have gotten the adoption we have today. So I think it was really crucial. And I think the rewrite in total would have failed if we didn't have that, because we wouldn't have gained traction as fast as we did. And yeah, this was absolutely essential, even with a major new release. Another thing that we do is whenever we build a feature in JUnit Jupyter, we kind of look to implement it in a way that we have an extension point that we then implement to achieve the feature. But that extension point is kind of generally useful enough for other people to also use it for maybe a different purpose or implement this slightly differently, because we don't always get it right, at least not at the first attempt, right? If we implement something new, of course, we do brainstorming, we ask for feedback and everything, we ship milestone releases, but sometimes the feedback comes in late, and so that's kind of our way of implementing things, and it has turned out to be useful, because in some cases, these extension points that we've added were useful in kind of ways we never imagined when we introduced them. So people could do some things with them that they couldn't without this extension point, and we then down the road didn't necessarily have to implement something else to achieve this new feature that they did. So that's kind of yeah, our thing, and has worked out pretty well. We mark new features as experimental in the initial release. Not everyone pays attention to that, but it gives us some peace of mind that if we do want to change things in a kind of maybe slightly breaking way, after we have initially shipped them, you can always point to like, yeah, it's been experimental, so sorry. We have a good reason for changing it because it kind of, does this and that better if we do. So that's kind of, yeah, a way of marking this. So we have our own API annotation for annotating like all public types and annotations and so forth to kind of indicate what their status is in terms of stability. And we do regularly go through them and promote them then. Maybe not initially in a subsequent release, but in the release after, we usually promote things that have received positive feedback, or at least mostly positive feedback. Yeah, another thing, smaller thing, is automating the updates of build and project dependencies. I think that's really important for us, especially since we're kind of a small team and don't have time to work on it like every day. If you want to kind of pick up the project after having maybe taken a break for a couple of weeks, you don't want it to be super outdated and the first thing you'll do is update dependencies and or download the old version of Gradle again that you haven't used in the last 6 weeks and stuff like this. So it's really important for us, especially for the smaller repositories that we have, like API Guardian, which is this API annotation, or OpenTest4j, which contains some common exception classes that we use, to keep those up to date, right? So basically they get security updates. I mean, they have not that many dependencies, but also Gradle, the build tool that we use, is being updated constantly and kept up to date. And that's just really, yeah, a good feeling to know everything is in good shape and you can pick it up and implement something and ship it without having to worry about first fixing the project for like a day. Yeah, and we've recently migrated actually away from Dependabot, which is GitHub's own kind of dependency update thing, which is not as powerful as Renovate, which we now use. And we had a variety of other tools in place that we have now basically gotten rid of. Instead of we are using now Renovate, and it's, yeah, I can recommend it so far if you're looking to adopt that. One obvious thing, of course, we want to have CI builds, but we have put some thought into like what CI builds are actually useful for us and also for contributors. We actually had quite a long journey. Initially used Travis, then had our own Jenkins instance. Used Azure Pipelines, which was just before Microsoft acquired GitHub, and then we switched to GitHub Actions. And yeah, now we're using GitHub Actions. I mean, of course, you can have your own thoughts about YAML and getting there, right? But it works pretty well, and it allows us to do what we need to do. And what's useful for us is that we can test against early access versions of Java, so we do that kind of constantly. All the new early access releases are being tested. We test on different operating systems, so that's not just important to know that JUnit runs on those, but also like, if a build runs on those operating systems, we can be pretty sure that if someone wants to contribute and use that operating system to do so, they can. All right? So this is also about the experience that contributors get when they want to submit a pull request, for example. And we publish documentation and snapshots on every commit using ASCII Doctor, so that's also really useful. So to know that not just before the release everything builds still, but we can actually publish stuff and we can build the documentation and we are ready to release basically at any time. One maybe a bit more controversial thing is that we enforce code formatting in the build. So when you don't adhere to the right formatting, the build will fail. We use a plugin called Spotless for this, which can also format the code, that has the violation in formatting. Yeah, it's sometimes a bit painful. If you forget this, the build will be read, and you have to fix it, right, by running spotless apply. But it saves us from having to discuss about white space in pull requests when we would rather focus on more interesting things, right? So that's kind of the trade-off here, and I think picking this end of the scale has been proven to be good for us, at least, right? So, of course, every now and then in the team we discuss, shouldn't we switch to this other formatting? But yeah, we probably won't, right? Because we would reformat the whole code base, and that rarely justifies itself. Yes, we also automated some architecture principles that we want to check for. So we check for cycles between packages, that there are none. We have this API notation, as I mentioned. So we verify that each public type actually has an API annotation, so it kind of declares its status. Recently, I've added a check for the consistency of the element types declared with the target annotation, because we have some annotations that are actually repeatable. And yeah, if you don't have those consistent between the actual annotation and the container annotation, things don't behave the way you want them to. And we use JUnit for that, which is a really flexible tool to kind of implement your own checks for this stuff. And I think it's, yeah, I can highly recommend it for sure. It's really proven useful. And yeah, I would use it in any new project if there's anything to check for that I can do statically as part of the build. Speaking of the build, for us, I think it has been really, really good to keep it fast and free of deprecations. So especially important if you don't have a lot of time and you come to the project, you know, after like having taken a break for a couple days, weeks, and you know, you can get stuff from the build cache, and we also have build scans. Thankfully, we have the Velocity instance from Gradle Inc. that helps us diagnose like unexpected cache misses and also, you know, find deprecation warnings and fix them, verify that they are fixed, and also you know, look for bottlenecks in the build. And yeah, so I cannot stress this enough. If the build is really slow, no one wants to work with it. This is also true for contributors who are picking this up, right? If they have half an hour of a build, maybe they have lost the motivation already by that time to actually contribute something. All right, that concludes like the first category of technical things. I want to also talk about some people issues or people things that we learned along the way as a team. One thing is that building a relationship with our stakeholders was really important. So I mentioned this in-person kickoff meeting that we had with IDEs, build tool vendors, and so on. And this really helped because then we had, you know, a point of contact into Eclipse, into IntelliJ, and so on, into Gradle. To, you know, if we do it this way, would you actually consider it, you know, to adopt this and stuff like this? It really helps. Of course, you can open issues on an issue tracker, but if you have like a personal relationship with someone, it's much easier, you know, to send them an email and, you know, ask if they maybe can, you know, speed things along, and or even meet to discuss this, you know, and see where we end up. And yeah, I think this was really important to get IDE support basically from the first release that we shipped. A sadder thing is that conflicts will happen. So naively we assumed, you know, we just built this new great team and we would all work together in harmony and everything would be great. And yeah, it was so for a while, but over time, I guess things built up and there was a conflict between two people that we had on the team. Of course, we tried talking to them. I guess nothing can really prepare you for this because every such conflict is different. So we tried to resolve this, but in the end, someone decided then they had to leave the team to resolve this. And yeah, this was of course sad for the team. We lost some really good developer, but in the end, I think it was better in the long run that we did this way, or that they decided to do it this way. Yeah, so it does happen. Even in a team of volunteers, you might have this happen to you. Of course, there's toxicity on the internet, as you're all aware, right? So some comments on issues maybe that you haven't addressed for 3 years or 4 years or whatever, right? And why is it still not done? And stuff like this, right? And they can get even worse than that, of course. Yeah, we talk about such things in the team when they happen. It's useful to have like a code of conduct in place to kind of shield from the worst behavior. But I think it's especially important that you send a clear message as soon as possible that certain behavior won't be tolerated before things get, you know, worse and worse. So I think you should act early to prevent escalation. And yeah, I mean, we had these issues whenever I opened them and there was a new comment. I then, you know, I don't know, lost all will to contribute and did something else with my evening. So, you shouldn't have those that much. And yeah, if you do, discuss and talk about it, it helps. We do weekly team calls. So even though we are kind of not in one company, we have a weekly call set up for an hour where we kind of triage new issues, discuss certain pull requests maybe that have been submitted in the meantime. And for me, this always is a new source of motivation. I go out of the meeting and say, we just need to finish this and do these two little things and it's done. And then maybe I spend the hour or 2 hours in the afternoon to actually do it. And something has been done, and that also motivates other people to get something done, and so forth. So this is really something simple that we do. That is, a great thing. I can only recommend doing this, even if you're a rather disconnected team. Even better are in-person team meetings. This is a snapshot from the last one we did in Zurich last year. And yeah, this is fun to just come together as a team. Also have some fun at the time, have a couple days where you can work together on something and really progress on something that maybe you've been stuck on by yourself and you never found the time maybe in this disconnected fashion. So these are really useful, and we also have the money to organize them every now and then. So yeah, I highly recommend it. And we're also doing one again in November, and after that we will participate in this Hack Commit Push conference. It's like a hacker garden kind of event. So if you're interested to meet the team, this is a chance to do that. It's like on the 23rd of November in Switzerland. And yeah, just for your information, basically. We are always keeping an eye out to kind of, grow the team potentially. So if a contributor is doing a great job repeatedly, we discussed within the team whether we should ask maybe them to join the team, to get fresh motivation into the team and grow it in a way, so then it's on more shoulders. Yeah, obviously we then schedule a call with them to get an idea if on a personal level we could work with them, and also to give them a chance to ask questions. And we've done this a couple times, and it has always been a good success so far. So I think it's also important to keep that in mind when reviewing PRs and you're impressed by someone's work, to ask them that. All right, last but not least, some lessons learned in the project management category. First one is kind of trivial. No one will test an alpha release. So let me say, if you call it alpha, you're kind of saying, this is unstable, don't use this, right? So why do you expect people to use it? So that's what we did. We got some feedback, of course, so almost no one will test it. But yeah, it's usually not a good idea. It doesn't really send a vote of confidence or anything, right? So maybe just call it milestone 1 or something. It's more likely that people will pick it up and try it that way. One thing on a personal project management level for me and also for the team is to have small, manageable and interesting tasks. So if you're working on a project mostly in your free time, you want to spend your free time in an interesting way, ideally, right? So, and if you only have these huge tasks that you think, I need to do this and that, where do I even start? You won't, progress on them in like an hour or so, because you don't know what to do first. So to have a list of small tasks is kind of essential. And if you can, get them done in a few hours each, you can actually make some progress in this way without, spending the whole week on it. And it also avoids you like doom scrolling through your GitHub notifications and being overwhelmed and closing the laptop and doing something else, right? Which is okay, of course, at sometimes, right? But if you always do this, the project will not progress at all. So I've certainly done this a couple times. Yes, we experimented with auto-closing issues. So we used a Stalebot, which is a GitHub bot that kind of you can configure, of course. But we used it for auto-closing issues and pull requests without any activity in n number of days. Yeah, the feedback was mixed, I would say. Some saw it as rude and not being interested in the community, because at some point, sometimes we didn't get back to the people that even replied after the Stalebot did something and so forth. So it didn't really work out in the way we hoped it would. So we stopped using it on PRs entirely, and we only now use it on certain issues that have a certain label, and everything else we we leave be. And this is something that, yeah, is okay in this way, but the effect then is also not that great. You don't get rid of all the issues and they magically solve themselves, right? That's not how it works. And it's okay. I mean, now that I have a bit more time to work on JUnit again, sometimes it's a bit, yeah, weird to get back to an issue that someone has commented 4 years ago with a question and you have never gotten back to them. But sometimes that happens, and it's okay. You know, it's a free time project, and that's how things work sometimes. Yes. Also, if you do get a PR, that's great. You want to embrace contributions, but sometimes it's, if you do like a line-by-line feedback and do this here and do that there, and sometimes it's easier to finish it yourself, you know, in the interest of time. Of course, you want to coach people to become better contributors, but you know, at some point you have to, you know, make a cut and say, okay, I'm going to take over now. Thanks for your PR. This is what I did and why. And you know, they can also learn this way. Maybe it's not as effective in terms of the learning experience than if you had coached them step by step. But also you have to be mindful of your own time. And sometimes it's okay to do it this way. We have a definition of done for pull requests, which we check. So that includes like no fun tasks like writing documentation and release notes. For us, it's essential once a PR is merged that it's potentially shippable. We don't have to do another round of fixing the documentation or doing this and that. It should be kind of self-contained. Everything should be in there, and that includes those 2 points. And yeah, I mean, since we're using ASCII-Doc and it's in the same repo, that is not usually a problem. Of course, if you have someone that's not a native speaker, submit a pull request. Sometimes it's easier for them to adjust the code and write the tests, but maybe they're not as good as you know, in writing documentation. As I said, then the earlier thing applies. You can write the documentation or finish it at least yourself and finish the PR this way, rather than giving grammar advice to everyone, right? And doing that. So that's also okay. But then once you've done that, the PR is merged and includes the changes that you've made as well. You're basically ready to go, ready to ship. All right. So summing up, then versus now. So the status of JUnit in 2014, we were a very loose group of committers with little to no time. We had never met each other in real life. We just had contact via email. We had no funding at all. And as I mentioned, you know, we had this hard to maintain and evolve architecture and extension model. So things were kind of bleak in a way. At least that's how I see them now. Of course, you know, in hindsight, things might seem different. And today, in 2024, we have a core team of 5 people with some time. Of course, not everyone has time all the time, but we have these weekly team calls that keep it alive, at least give everyone a chance to participate in discussing things and direction of the project or individual PRs. We have some funding for in-person team meetings. And we have an architecture that now actually allows evolution and has proven so over the last, you know, 5 to 8 years that it actually does that. And the feature releases are kind of an indicator that it works. And there's actually more, because the Sovereign Tech Fund is investing in JUnit in 2024 and 2025. So the Sovereign Tech Fund is actually a German government program that aims to strengthen the open source ecosystem. And they invest in foundational technologies that enable the creation of other software. And as a testing framework, we kind of fit that description. So we have applied for funding and we've been accepted. You can also read that on their website here. And that means that I will be able to work full-time on JUnit for the next year or so. And this is just a list of parts of those milestones that we have negotiated as part of the contract with them. So we will improve the project, like release automation and some things that have been that are not perfect. We will try to focus on documentation and really restructure that in a way that is more easily consumable. Better test reporting, but also new features like parameterized test classes, because those allow downstream projects to write more effective like TCKs, for example. and stuff like this, or better Kotlin support, because JUnit is also used for Kotlin projects, and to get them to use JUnit in a better way is also important to us. So yeah, that was a big thing that we got this funding basically, or this investment, and yeah, I started on this in September, and so far it's going pretty well. I'm really happy about that. So things are looking up definitely, and yeah, this is a good time to be working on JUnit. So key takeaways from today. Yeah, open source projects can be successful without a company backing them. It can be hard sometimes, let me tell you, but it is possible. It requires a certain amount of idealism, dedication, and stoicism, I would say, as well. Just keep going, and despite maybe not getting much feedback on this and that, or comments like, when is this ever finished, and stuff like this. But you have to find a way to deal with that, and stick with it, and then you can actually really achieve something, and it can help shape your career. Because I think for me personally, I worked at Gradle before becoming self-employed, and I think it would have been much harder to get that job joining the Gradle build tool team without having like this kind of open source experience already under my belt. And last but not least, it also gives you purpose, to do something that's kind of meaningful, that if you make an impact there, helps so many people write better tests. That gives me motivation and purpose, and yeah, I think that can really be a good outcome as well, even though it takes a lot of work. All right, now we have a little time for questions, if you have any. There's a microphone there.
Hello, and thanks a lot for the presentation. One question regarding the definition of done in the pull request. Do you think that this really works? Or do you have the experience that sometimes people are just checking the checkboxes and say, okay, yes, I don't have to-dos and the documentation is up to date, but in fact it isn't?
Yeah, so technically the contributors can check the checkboxes themselves because it's just in the issue, in the description, which is a markdown thing in GitHub. But we do check basically them as well. So whoever merges the pull request does check for them. And I found that people are most of the time honest about things. If they haven't written the documentation yet, they don't check the checkbox, for example. So I think it works mostly. Of course, it's not perfect, right? You still need to take a look at, okay, do the tests actually test what they supposed to do and all that stuff. The checklist alone doesn't give you that, of course. All right, any other question? There's one.
Hi, thanks for the presentation. And the technical part of your...
Can you speak up a bit? I can't.
Sorry.
I can hardly hear it.
In the technical part of your presentation, you mentioned that you use the API annotation for signaling that this is a public type. Can you expand on that? Why did you need that?
Yes. So so we wanted to limit what is actually considered our public API, or what is actually considered stable, or what is internal maybe, and just public for technical reasons, for example. Because we have, for example, we have a JUnit platform commons library where we have some utils that we use across the code base, but we don't want to guarantee that we never change them or remove methods there, and that's why we want to mark this as internal, even though it's a public type. It has the API annotation on it that says it's internal, so that means you shouldn't use it. In addition, we have like a little snippet in the Java doc that says, warning, don't use this thing. Of course, people can still use it, like technically, nothing prevents them. They don't get a compiler warning or anything like this. I mean, we could have written a compiler plugin, I guess, but then people would have to pull that in. So that would have kind of also defeated the purpose. Yeah, so that's why. I mean, just, that in Java, things have to be public for technical reasons sometimes, or we want to make things experimental, so they need to be public so people can use them, but we don't want to say that they are stable yet or maintained. Does that answer the question? Okay. Any other question? This one there.
It was a very nice presentation. Oh, this is weird. Did you ever remove public types again after the feedback from the community, or if there was no feedback, like you had the idea that this might be an interesting feature, but it didn't really, it wasn't picked up really by the community. Did you delete any of those APIs ever?
I think we at least changed the class name of some public types or something like that in a release. So it's something that was experimental. We basically renamed it to something else because, or changed the method inside an interface in a breaking way because it was still experimental. So yes, we did do that. But of course, you try to avoid that as much as possible. Even if it's marked as experimental, people will use it, and it might break something. Yeah. So I wouldn't say we do it very often.
Is there any plan to have a version 6?
Well, sorry, didn't get that.
Is there a plan to have a version 6?
Well, yeah, I wouldn't call it a plan yet. I mean, so we've been discussing this again and again, of course, right? So right now, JUnit 5 is compatible with Java 8. There's even a JEP out there from the OpenJDK team to kind of, they are pushing for a new kind of model of how to develop things. That libraries should, adopt a more strict JDK baseline sooner and stuff like this. So we have, in the context of that, we had the discussion whether we should change something. Our stance is basically, as long as we don't need a higher JDK baseline to provide a feature that people on that Java version, want to use, we won't do it. Because otherwise, it's just going to create more work for ourselves. And it's kind of tied to increasing the major version number. So we would only do that, coming back to your question, we would only bump the JDK requirement if we did a new major release, right? The other reasons for doing a major release is to get rid of deprecated stuff, right, of course, and that sort of thing. But we haven't actually accrued that much yet of that, I think, right? So I think overall, I mean, it's a trade-off, right? And the disruption it brings to do a major release in that sense with breaking changes in it is currently not yet worth it, I would say, right? But we are considering maybe doing a release like that, but we haven't any concrete date or anything. It could be next year, it could be in 5 years, I don't know, right? So it kind of depends on how Java evolves as well, if there's any new thing. For example, I mean, records have been introduced, right? But you can write a test as a record if you want right now. So you can put test methods in records, and like I mentioned, parameterized test classes, for example, which, if you want to avoid the boilerplate, a record would be nice because you inject stuff into a class, basically the constructor parameters are just declared in one line. But we can support that with the Java 8 baseline, no problem, since we use reflection anyway. So, there's no big reason why we would need a major version right now. So, we're playing it by ear, seeing what happens, but there's no concrete plan as of now. All right. Thank you.